EES, which is pronounced ease, is an acronym for Engineering Equation Solver. In a previous video, we saw how to build a curve fit for a set of data that were used in a plot. And we did this by selecting Curve Fit from the Plots menu, and that allowed us to access ease's internal curve fitting capability through this curve fit dialog. We can access the same internal curve fitting capability in ease using the procedure curvefit1d for data that is not plotted but is contained in an array. The procedure curvefit1dt can be used for data that's contained in a lookup table. These procedures allow curve fits to be generated programmatically using a set of data that might be generated within ease or loaded into ease as the program executes. And then this capability allows the curve fit to change on the fly as the data itself changes. So as an example, here are the thermal conductivity as a function of temperature data that were used previously. And we're going to now place these data into an array using a duplicate loop here and array notation for the conductivity. To generate the coefficients of a curve fit to these data, we need to use the curvefit1d procedure because the data are in an array. And the calling protocol for the curvefit1d procedure is shown here. So it's a procedure, which is something that is discussed in more detail in section 3.3 of Mastering Ease. Procedures are really similar to functions, but they allow multiple outputs, and you have to precede the procedure statement with a call keyword. So in the procedure here, you can see that any argument to the left of this colon is considered an input, while those to the right of the colon are considered outputs. So inputs are typically provided to the procedure, and then output variables are assigned by the procedure. So for this procedure, curvefit1d, the first input is a string, fit type $, and that string is going to specify the functional form of the curve fit. And the choices that you can make correspond to the standard choices that are available in the curve fit plotted data dialog, and they're summarized here in this table. So you can see these are the different strings that you can select, and these are the associated form of the curve fit. The second and third input arguments are arrays that contain the data. So the second one contains the independent data, and then the third one contains the dependent data. The first outputs are the unknown coefficients associated with the curve fit. So the number of these coefficients depends on the form of the curve fit. And then the remaining outputs are completely optional. Right? You don't have to provide variables that will be assigned to these outputs, but if you do, these outputs include the RMS and bias errors, which we talked about previously. The RMS error being an indicator of the fit, and then the bias being an indicator of some bias between the curve fit and the data. The output here R2 is the correlation coefficient between the dependent and the independent variables. And then this last output is an array that contains the standard error associated with each of the curve fit coefficients. And the standard error is defined as the square root of the estimated variance of the parameter. So in order to use the procedure curvefit1d for this particular example, I would use the ease code shown here, right? So here I'm going to have a string that identifies the curve fit. So I'm going to use a best fit second order polynomial fit, and then the independent data are the temperatures, the dependent data are the conductivities. So those are two vectors. A second order polynomial has three coefficients, a0, a1, and a2. So those are the first three outputs. And then the next outputs are the RMS and bias errors, and finally the correlation coefficient. So when I hit solve, you can see the coefficients and the fit parameters in the solutions window. And again, the nice thing about this is we can use the curve fit directly within the program. So for example, we might want to determine the integrated average thermal conductivity between two temperatures based on the curve fit to these data. So here, integrated average conductivity between TC and TH is defined by this equation. This is a concept that comes up a lot in cryogenic engineering. If we substitute the curve fit in here for the thermal conductivity, we get this solution in terms of the coefficients, and we can implement this solution in ease and calculate the integrated average thermal conductivity between any two temperatures. And the nice thing about this is if for some reason the data itself changes, the curve fit will automatically adjust. So here, if I go in and change some of these data points and then run again, I'll get a new best fit curve and a new, obviously, integrated average thermal conductivity. If the data that you want to curve fit exists in a lookup table, then they should be curve fit using the curve fit 1DT procedure. And the calling protocol for the curve fit 1DT procedure is shown here. And it's pretty similar to the curve fit 1D procedure, but some of the inputs are a little bit different. The first input is still a string that identifies the fit type, but now the remaining inputs basically tell ease where to go to get the data in the lookup table. So the second input is the name of the lookup table, it's a string, and then the third and fourth inputs are the names of the columns that contain the dependent and the independent data. And then actually the fifth and sixth inputs are the rows that you want to use. So you don't have to use all of the rows in those columns. You can curve fit just a subset of those columns or just a section of those columns. The outputs are exactly the same as they were for curve fit 1D. So if I place these data into a lookup table as I've done here, then this is the ease call that would fit the data to a second order polynomial, and the coefficient should be exactly the same as what we saw previously. And again, this is really nice because you may have a bunch of sets of data in different lookup tables, and if you do, then you can load them in and simply just change the name of the lookup table, and ease will automatically, without making you prepare a plot or anything like that, will automatically perform your curve fit. Okay, so this is one of a series of tutorials that's meant to describe the operation of the EASE software. If you want to get more information about EASE, obtain the software, or access more of these tutorials, please go to the website fchartsoftware.com. These tutorials are excerpted from the book Mastering EASE, which can also be obtained from the F-Chart software website.